Hey guys, welcome back to another round of chemistry notes. In this video, we are going to talk about the activity series. So before we can talk about the activity series, we need to talk about activity and what that is, because it means something special in chemistry. For metals, to have a high activity means that it's easier for them to lose electrons and form cations. Those are your positive ions. For nonmetals, to have a high activity means it's easier for them to gain electrons and form anions, which are your negative ions. So in general, activity is just how easy is it for something to undergo a reaction. For metals, that means losing. For nonmetals, that means gaining. But for any, just how easy is it to undergo a reaction. So we have something called an activity series, which is a list of elements organized by the ease with which the elements undergo certain reactions. And this is on the back of your periodic table. You don't need to memorize this. It will be given to you. But you can see we've got two separate series, one for metals and one for nonmetals. And up at the top, you have really high activity metals. And down at the bottom, you've got lower activity metals. So lithium is your highest activity metal, fluorine is your highest activity nonmetal, and then down here we've got very low activities. These are not very likely to undergo reactions. So the point of this series, it's used to determine whether a single replacement reaction will occur. Because remember, single replacements are when you have an element and a compound. And that element comes in and it kicks a different element out of the compound. Well, as it turns out, that's not always going to happen. Sometimes you'll put an element together with a compound and nothing will happen, and that has to do with the activity series. So the reaction will only occur if you have an element replacing a less active element. So for example, lithium is our most active metal. Lithium can replace any metal. So like if this is lithium out here, this reaction is going to happen. But something like, I don't know, tin, that's a pretty low activity. So if you have tin as your element trying to replace anything above it, any of these metals up here, so calcium, maybe in calcium chloride, this reaction is not going to happen because tin is low and it can only replace the things below it. Now, if we were looking at something like silver, if we had silver in our compounds, tin can replace silver because tin is higher activity and silver is lower activity. And this is true for nonmetals as well. The same rules apply. Notice that hydrogen, we've talked about hydrogen being sort of the awkward element. Hydrogen shows up on your metal activity series and on your nonmetal activity series, and it's pretty low activity for both. But just be aware that it is there. Keep an eye out for that. So we're going to sort of add this knowledge into predicting products. We learned how to do that last time, but we're going to make it just add one step to the process. If you are trying to predict the products for a single replacement, make sure that you check the activity series first. Because now, sometimes instead of writing products, you're just going to write no reaction. So if you look at your activity series and the single element is more reactive than the element in the compound. So your single element's up here and the element in the compound is down here. Yeah, that's going to happen. That'll be a reaction. But if the single element is less reactive, if your single element is down here and it's trying to replace something up here, that's not going to happen. It can't do it. So instead of having to write out the products and the charges and the balancing and all that good stuff, we can just write no reaction because there are no products. That reaction will not occur. So let's do some examples of this. Our first example says, can iron replace manganese in a single replacement reaction? And then why or why not? Well, iron is right here, and then manganese is right here. So this is like saying we have iron as the single element trying to replace manganese that is, I don't know, in a compound with something. Can this happen? And the answer is no, because iron is a lower activity metal than manganese, so it can't replace it. If we mix these two things together, they're just going to stay put. We're not going to have iron doing the thing where it comes in and kicks this other metal out. Nothing will occur. So instead of trying to balance charges and balance reactions, we would just write, if we were given something like this, we would just say, no reaction, nothing happens. Looking at a non-metal example, it says, can bromine, so here's bromine, can bromine replace iodine in a single replacement reaction? And then why or why not? So again, this would be like bromine is our single element, and we've got some metal paired up with iodine. Can this occur? Well, this bromine is a higher activity than this iodine that's in the compound. So this bromine, yes, can come in and kick this iodine out. And then you'll have bromine paired up to whatever this metal is and iodine all by itself. So yes, this reaction can occur because bromine is a higher activity non-metal, so it can displace iodine, which is a lower activity non-metal. All right, let's do this with actual reactions now, predicting the products and all that. So here we've got magnesium and chlorine together in a compound, and we've got zinc all by itself. So hopefully by now this is sort of jumping out at you as a single replacement reaction when you have a compound paired up with just an element. But before, we would have just gone straight in, we would have kicked out magnesium, we would have put zinc in here, we would have gone and balanced. Now, that is maybe not something we should do. So we're going to go find, we've got two metals in this problem. We've got this metal and this metal. Our single element is a metal. So we're going to check the metal activity series. And we've got magnesium right here. And we have zinc. Zinc is down here. So we have this low activity element trying to kick out this higher activity element. And it can't do it. Lower activity elements cannot replace higher activity elements, so this will not occur. And we can just write no reaction. We don't have to try and figure out our products. We can just say this reaction will not occur because zinc is lower activity than magnesium, so no replacement can occur. Take a look at another one here. Next, we have solid aluminum is placed in water vapor. This time we're not given the reaction. We're going to have to write it out for ourselves. So we've got solid aluminum, that's Al, S, plus, leave a space, water vapor, so that's just good old water, H2O, but in gas form. React, and then we can leave this blank for just a second while we check to make sure that this reaction will actually happen. So our single element is a metal, so we're going to use the metal activity series. We've got aluminum right here, sort of in the middle. And now we've got sort of a weird situation because water does not have any metals in it. But remember, we can write water as HOH when this hydrogen actually forms a positive ion and the hydroxide is that negative ion. So if this were going to happen, it would be our positive aluminum ion coming in to replace our positive hydrogen ion. So those are the elements we're going to compare, aluminum and hydrogen. So here's hydrogen down here, aluminum's up here, and aluminum is able to replace this thing that is below it. So in this case, aluminum can kick hydrogen out. This reaction will occur. So we can clean this up a little bit. So aluminum will come in. It will kick out the hydrogen. The hydrogen will have to go do its own thing. And we will end up, our products will be aluminum 3+ pairing up with hydroxide 1-. So that product will be AlOH3 plus, when hydrogen goes off, does its own thing, it goes back to being good old diatomic, oops, a little hard to see there, diatomic hydrogen H2. So now, actually cleaning this up. Now we need to balance this. And since it is a replacement type of reaction, our polyatomic ion is staying together. So we can do this as aluminum and hydrogen and hydroxide, and then aluminum, hydrogen, and hydroxide. So we've got 1 and 1 and 1, 1 and 2 and 3. So aluminum's all set. We can work our way down, look at hydrogen next. We can put a 2 here. And that'll give us 2 hydrogens and 2 hydroxides on the left. Then we've got 2 hydroxides on the left and 3 on the right. So hopefully at this point you've sort of figured out some pattern recognition. We actually need the lowest number they're going to have in common is going to be a 6. So if we put a 2 right here, then that'll give us 2 times 3 is 6 hydroxides. And if we put a 6 in here, that'll give us 6 hydroxides and 6 hydrogens, which means we just need to put a 3 here to give us 6 hydrogens. And this is how we will end up with our balanced equation. If we wanted to write it out with water written correctly, we could write it out again. 1 mole of solid aluminum reacts with 6 moles of gaseous water to produce 2 moles of aluminum hydroxide and 3 moles of hydrogen gas. So again, it's the same steps as before. You just need to do that first step of, do I need to actually work this problem? Double check, make sure the reaction is actually going to occur. Let's do one more of these. Next we have iodine gas reacting with potassium fluoride. So in this case, our single lone element is a nonmetal. So we're going to be looking at whether iodine can replace the nonmetal fluorine. We will be looking at our nonmetal series. So here's fluorine up here. Here's iodine down here. Iodine is trying to replace something much higher on the activity series, and that is not possible. Fluorine is the most active element. If it's in a compound, it's staying in the compound. So once again, we can just say no reaction. Iodine is lower activity than fluorine, so no replacement can occur. Fluorine is not budging. All right, next in your book, you have 6 practice problems. Some of them require you to write the reaction, some of them already give it to you. So you need to check your activity series. If you're working this at home, that is on page 6 in your booklet. Use your activity series to decide whether the reaction will occur, and if it does, predict the products and balance the equation. When you're ready to check your answers, unpause the video. All right, hopefully this is what you got. All 6 of these reactions would actually occur. One thing to note that didn't make it into your booklet, on number 5, in order to solve it, you would have to assume that iron 2 is the ion that results, because there's no way to find that without it being given. So assume this answer, that the answer that is given for number 5 is assuming that it is the iron 2 ion that is formed, but that is not something you should be able to just come up with on your own. All right, if this went well for you, feel free to keep on moving, work on your quest, move on to the next video. If it did not go so well, go back and troubleshoot, see if you can see where you went wrong. As always, come into tutorials if you need extra help. Good luck and happy studying.